Okay, in this video we're going to go over the 1.3 worksheet. So what I want you to know at this point is you're going to find and evaluate derivatives and find tangent lines, and you want to use proper notation. So it says for each problem, write the equation of the line tangent to the function at a given point. And your answer should be in point-slope form. So remember that is this. Okay, so that's our goal. So here's our point, here's our x, here's our y. So right away we already know y minus 2 equals some slope times x minus 3. So find y prime. That's going to be 3x squared minus 6x. Evaluate y prime at an x value of 3. So that's going to equal 3 times 3 squared, which is 9, minus 6 times 3. So that's 27 minus 18, which should equal 9. 9 is our slope. Done. Okay, let's do the next one in a different color. Okay, so it says, so we'll just draw a little line here in green. Same idea. So I know the point is 2, 2. So already I know y minus 2 equals something, some slope, times x minus 2. Get your first derivative, which is your slope, your generic slope. Evaluate that where x is 2. So this is 3 times 4 minus 4 times 2. So that's 12 minus 8. Looks like that should be 4. And that's done. Okay, let's go to the next page. Find each problem. For each problem, find the derivative of the function at a given value. So the given value is your x. So y prime equals 2x plus 4. Y prime evaluated at negative 5 equals 2 times negative 5 plus 4. So that is negative 10 plus 4, which should be negative 6. So y prime evaluated at negative 5 is negative 6. Okay, the next one. Same idea, y prime equals negative 3x squared plus 8x. Y prime evaluated at positive 4 is negative 3 times 16 plus 8 times 4. So negative 3 times 16 should be a negative 48 plus 32. I believe that gives me a negative 16. And that's what y prime evaluated at 4 is. Okay, so let's keep going. Okay, the next one says for each problem, find the slope of the function at a given value. It's the same kind of problem. So let's just see, where is x is negative 2? That is right here. Whoops, let me put an x. So right there, that's where it is. So to find the slope, I'm going to go ahead and just draw it in. There it is. It looks positive to me. So if I don't get a positive, then something is wrong. Okay, so now let's do the work. Let me just get rid of this first. Okay? Okay, so what's our work going to be? Y prime equals 2x plus 6. Evaluate that slope where x is negative 2. 2 times negative 2 plus 6. That's negative 4 plus 6. So I'm finding out that y prime of negative 2 is going to equal 2. That seems reasonable given the sketch. Okay, same idea, next problem. Where is 3? I'm looking right here, and I'm seeing right there is 3. Go ahead and draw the tangent line. Now that looks steeper than the other one, and I'm going up by the same increments. So I'm expecting a steep positive slope. So let's do our work. Y prime equals 3x squared minus 6x. So y prime of 3 equals 6x minus 6. So that's going to equal 6 times 3 minus 6. 6 times 3 is 18, and 18 minus 6 is 12. So that slope I got to be 12. So let me just see what I just did. So 3 times 2 is 6. All that looks good. So let me just pause this for just a sec. Okay, so let me just figure out what I just did. I'm just going to erase this little guy because I think I lost my head when I was plugging in. So this is 3 times 3 squared minus 6 times 3. I think I took the derivative again. I'm not sure what I did. So let's get this the correct way. So this is 9 times 3, which is 27, minus 6 times 3, which is 18, and that gives me 9. And that seems like a better answer. So that slope is 9, and this other slope was 2. That seems relatively correct. Okay, let's go on to the next problems. This says find all points on the graph where the slope of the tangent line is equal to 0. Okay, so let's find the generic slope. F prime of x equals 18x minus 8. What does it have to equal? It has to equal 0. So that means 18x equals 8. So x is going to be 8 over 18, which is better as 4 over 9. Now, they say find all points. So that means I have to plug in 4/9 for the x. So f of 4/9 equals 9 times 4/9 squared minus 8 times 4/9 plus 4. Okay, so when you do this, you should end up with 20 over 9. So therefore, your point is going to be 4, 9, 20 over 9. Okay, so see if you can get that. And that's all they've asked us. You only have one place where that slope is going to be 0. What is that place? That place should be the vertex. Think about that. Okay, look at number 8 now. And number 8 says, find all points on the graph where the slope of the tangent line this time is equal to -5. Find the slope of the tangent line. 3x squared plus 18x plus 19. That has to equal -5. Okay, so let's figure that out. So that's 3x squared plus 18x. If I added 5, I would get plus 24. Okay, so I'm thinking I'm going to factor out a 3. I get x squared plus 6x plus 8. And that is factorable. So I get what? X plus 4, x plus 2. Okay? So that means I have 2 values for x. So 1x is -4 and 1x is -2. If I graph that function, there are 2 places where the slope of the tangent line drawn to that cubic function is going to equal -5. Those 2 points are at x equals -4 and x equals -2. Plug those 2 x values back into your original function, and you should find that the 2 points are -4, -6, and -2, -20. Okay, that brings us to the next problems. So let's go to the next page. Okay, differentiate this. All right, well, that kind of looks messy, but it's really not as bad as it looks. Let's rewrite that. So this is h of s. I'm going to make my s really deliberate. So radical 2, that can stay. This is s to the 1/3 plus radical 2, that can stay, and this is s to the 1/5. Take your derivative. And I'm going to make that look not like a 5. This is going to look like an s. Okay, so what do I get? I get 1/3, so radical 2 over 3 times s. 1/3 minus 3/3 is to the negative 2/3 plus radical 2 over 5 times s. 1/5 minus 5/5 is negative 4/5. And that's all there is to it. Okay, this is in Leibniz notation. That means this is your function, and this is your derivative right there. Let's say I didn't want to go right to taking the derivative. Let's say I want to do this. Y equals 2/3 x to the 3/2 minus 3/4 x to the 3/5. Y prime is going to equal, what is 2/3 times 3/2? Isn't that just 1? And 3/2 minus 2 over 2 is 1/2 minus 3/5 times 3/4 is 9/20 times x to the minus 2/5. Okay, so right here on this line, without any other notation, I get to write x to the 1/2 minus 9/20 times x to the negative 2/5. And that's the end of that problem. Okay? So Leibniz notation. You have to remember that you don't have prime notation. If you want to work it out a little bit, go ahead and down in this box, I used prime notation. Then I took my prime notation answer, which is my derivative, and I placed it right here after the equal sign. Okay, so you want to know how to work with Leibniz notation. Okay, and that's the end of this video. I hope that helped.